Okay, when you're using carbon dating and using half-lives, okay, what you're going to do is you'll use the following function. Okay, the capital T is going to be your what the given half-life is. Okay, and often what you're going to do is, like we did with in that previous problem, you're not going to know what your original amounts are necessarily, but you'll know how much remains. Okay, so if you wind up kind of using this model as your value, okay? Or as the model, as the equation that you'll use for these problems. So if you see that there's 35% that remains, that's going to be the number that goes here in decimal form. 1/2 to the power of, the T is our unknown, and the capital T is the given half-life. And then you calculate the resulting equation. Okay. Just like what we did in the previous two examples, at this point you either use the solve feature on your calculator or you take the common or natural log of both sides. In this case it doesn't matter. I'll use ln because it's easier to type in, just one less letter. Okay, but if you calculate this, you get ln of 0.35 is equal to, I can move my power out front, so T over 5730 times the ln of 1/2. Notice this time the ln didn't cancel because the base or the input's not the same as the base. So I'll leave it in this form. I can then divide by ln of 1/2. At the same time, I can divide by or multiply by 5730. Okay, so these cancel, I'm left with my time. And so when I use the calculator and compute this amount, 5730 times the natural log of 0.35 and divide by the natural log of 0.5. I'm just going to put that 1/2 in a decimal form. I'll get my number of years, which is 8678.50 approximately. And that would be my solution.